Hello everyone. Today we are going to talk about rational numbers. And in the course of this lesson, I'm going to show you how to prove that a number is rational by solving these three problems. Without further ado, let's dive into it. By definition, a rational number is a number that can be expressed in the form of A over B. I'm going to explain this, where A and B are integers and B is not equal to 0. Now, what does this mean? This simply means that a rational number is a type of number that can be expressed in the form of 1 over 2. So 1 over 2 is a fraction in its lowest term, just like A over B. Okay? A over B is a fraction in its lowest term. Okay? Now, when you see a fraction like 2 over 4, or let's say 3 over 6, these two fractions are not in their lowest term because 2 can divide itself and 4 can also, 2 can also divide 4, something like that. So it's not in its lowest term. But 1 over 2, 3 over 4, or let's say 5 over 6, these are fractions in their lowest term. So if you want to prove that a number is truly rational, then you must be able to express that number in the form of a fraction in its lowest term. That is what it means. But when doing the expression, your b must not be equal to 0. B must not be equal to 0. For example, you can see that here we have a fraction in the form of a over b, where 1 can be said to be our a, and then our 2 can be said to be b, right? So you must not have something like 1 over 0. No, that's not acceptable. Okay, it must be in the form of maybe 1 over 2, 1 over 3. These are examples of fractions that are in their lowest terms. Okay, and then it says that a and b are integers. And what's an integer? An integer is just a whole number or 0. For example, 5 is an integer, 6 is an integer, -1, -3, and what have you. As long as it's a whole number or 0, it's an example of an integer. So that means that the top would be an integer or a whole number, and the denominator must also be a whole number. So these are the conditions, right, that you need to understand whenever you're solving problems when it comes to proving that a number is rational. Now let's dive into solving problems, and I'm going to show you how to express a number in the form of A over B to prove its rationality. Let's get right into it. Here are some questions that we're going to solve to understand better this very concept. It says, express the following repeating decimals in the form of A over B, where A and B are integers and B is not equal to 0. If you look at this number here, this is 0.3 bar, okay? 0. There is a bar on top of the 3. What does it mean? It means that the 3 is repeating forever. On your calculator, this might look like 0.3333333. The 3 keeps on repeating forever. For the second one here, the bar is on top of the 3. It means that we have something like 0.13333333. So whichever one carries the bar is the one that is repeating. I repeat, whichever one carries the bar, okay, this bar on top, okay, or wherever the bar is found, that number is the repeating decimal or the repeating number. If you look at the third one here, we have 3.245, okay? The 2 does not carry any bar. The front 3 doesn't carry any bar, but the 4.5 carries the bar. Hence, this is going to be something like 3.245454545, okay? The 4.5 keeps on repeating forever or till infinity. So this is these are examples of repeating decimals, okay? So if truly that these are rational numbers, then that implies that we can express these repeating decimals in the form of a fraction where the only common factor between the top and the bottom is 1. For example, if we can express them in the form of A over B, it means that the only common factor between A and B is 1. That's the only number that can divide the top and the bottom without the remainder. Okay, so if we can successfully express these three repeating decimals in the form of a fraction in its lowest term, that implies that these numbers are truly rational. They are different from irrational numbers. For example, the square root of 2 is irrational, okay? If you punch this on your calculator, you'll be getting 1.4 and, weird numbers. So you can't really convert the square root of 2 into a fraction in its lowest term or in the form of A over B. Why? Because this number is irrational. In my next video, I'm going to show you how to prove that a number is truly irrational. Now, let's start with the first one. Here we have number 1, 0.3 bar. Remember that this 3 is repeating. So what are we going to do? How do we do this? We say, step 1, let x be equal to 0.3 bar. I'm showing you how to solve this. Let x be equal to 0.3 bar. And once you write it this way, the next thing I'm going to do is now to copy it down and say x is equal to 0.3 bar. Good. The next step is to multiply by 10. We're going to, this is our left-hand side, okay? This part is our left-hand side. And here we have our right-hand side, okay? So the 0.3 is our right-hand side, while the x is our left-hand side. So what do we do in this case? The first thing to do is to remove the repeating decimal, okay? That's the goal of this whole process. We want to remove the repeating decimal. Now, what we're going to do is to multiply both sides of the equation by 10. Now, if you multiply this by 10, 10 times x will give you a 10x. This is equal to, please don't use a calculator when evaluating the part that contains the repeating decimal. What do? See what you're going to do. Once you multiply the left-hand side by 10, it gives you a 10x, okay? Always multiply by 10 to avoid confusion. Don't multiply by 100, don't multiply by 2, don't multiply by 3. Always begin with 10, and you must consistently multiply by 10, okay? So you multiply by 10, you multiply by 10. Don't multiply by 100 straight, unless you are a professional or you have an advanced skill in doing this. When you multiply by 10, you have 10 times x gives you 10x, which I've written down here. Okay, let me call this our equation 1, okay? Now, this gives you 10x. When you multiply this repeating decimal by 3, you have to move the decimal point one place backwards, okay? So once this decimal point crosses the repeating decimal, that bar, the bar on top, you can see that there is a bar here, it disappears. It now gives you a 3, okay? Then you put the decimal point at the back, but you must always bring back the repeating decimal. Why? Because it's repeating, okay? So it's repeating, so you must always bring it backwards, or you must always bring it back after moving the decimal point backwards, or one place backwards. So like I said, you multiply the first one by 10, it gives you 10x. Then the next, which is the right-hand side, when you multiply the decimal by 10, just move the decimal point one place backwards. Move it one place backwards. And once it crosses, just like something like this, you have a 3 bar. When the decimal point crosses, this bar disappears, okay? It disappears for the meantime, and it now becomes a whole number. But then when you drop the decimal at the back of the whole number, you have to bring back the repeating decimal, the repeating number again. That's how to do it, okay? Don't use a calculator when evaluating this, because you might end up getting confused. Okay, now since I've multiplied both sides of the equation by 10, we now have our equation 2. What do you do in this case? The next thing is to look at the right-hand side, look at the right-hand side of these two equations and see if you can subtract, because next thing we have to subtract in order to terminate or to eliminate the repeating decimal. When you look at this here, you ask yourself, what's the number in front of, let's say, the number that comes after the decimal? You can see that here we have 3. Okay, we have a 3 here. Okay, so this is 0.3. Okay, let me show you how it works here. So this is 0.3 bar. Okay, that's for equation 1. And for equation 2, we also have 0.3 bar. Now they are perfectly aligned and they can be subtracted. You can subtract equation 1 from 2 at this very moment. And this repeating decimals or these repeating numbers would be effectively terminated. But in a case where you have, for example, equation 1 has, let's say, 0.3 bar, and equation 2 has 0.23 bar, you can't subtract at this moment. You have to multiply again so that you can find something that looks similar to the next. Okay, they must be alike. They must be the terms must be the same. If they're not the same, you can't subtract at that point. But if you look at, for example, if you look at this, the right hand side of equation 1, you can see that it is perfectly aligned with the right hand side of equation 2. So we can now subtract. I'm going to say subtracting equation 1 from 2. Okay, so when you subtract, first of all, you subtract this 2. So it's not going to be 10x minus x. You have 10x minus x. This is equal to, so this is our equation 2. Okay, we now say 3.3 bar minus 0.3 bar. Okay, I've explained to you the point at which you subtract. If they are not perfectly aligned, I mean the repeating decimals, if they're not perfectly aligned, don't subtract. Okay, don't subtract. You only have to make them to appear the same before you can subtract. Now you can now use our calculator. So 10x minus x will give us 9x is equal to, so 3.3, you can just type 3.3 or punch 3.3 on your calculator minus 0.3. Here we have 3.3 minus 0.3, and that gives me a 3, right? We now have a 3 here. You've seen that repeating decimal has been effectively terminated. And in this case, we can now solve for x and see what we're going to get. To solve for x, we can simply divide both sides by 9 by 9. This they cancel out. We now have that our x is now equal to 3 over 9, and 3 over 9, if 3 divides itself, we have a 1. If it goes into 9, we have a 3. That means that x is now equal to 1 over 3. And this is our answer. We have effectively expressed 0.3 bar as a fraction in its lowest term, which is equal to 1 over 3. Okay, so that's how to do the conversion. Now, for you to verify your solution, punch 1 over 3 or 1 divided by 3 on your calculator. You'll see what you're going to get. You're going to get 0.333333, okay, to show that the 3 is a repeated decimal. And once you verify your solution and it's correct, you're done. Now you have to go on to the next one. So that's how to do it. Now let's try the second question here, which is 0.13 bar. Let's work on it and see what we're going to get. I'm going to copy it down here. This is the second question. We have 0.13 bar. Remember that the 3 is the only repeated decimal here. Now what am I going to do? I'm also going to follow the same steps I took in, or I used in the first question by saying let x be equal to 0.13 bar. Then I'm going to bring it down and say x is equal to 0.13 bar. And next up, I'm going to call this my equation 1. The next thing is to multiply both sides of this equation by 10. If I multiply x by 10, I'm going to have 10x is equal to, now when you multiply this decimal by 10, you just have to move it one place, okay, backwards. So when this decimal goes at the back of the 1, you now have 1, okay, then point, then you bring back the repeating decimal, you have 3 back, okay? So it goes one place, and then once it goes one place backwards, the number comes in front, and then you also have to bring back the repeating decimal. Don't forget to bring back the repeating decimal. It's very important, okay? So we say 10x is equal to 1.3. We can call this our equation 2. Now, the next thing I'm going to do now is to check. Can we subtract? Is it possible to subtract? If you look at this closely, you discover that for equation 1 on the right hand side, we have 0.13 bar, and for equation 2, we have on the right hand side 1.3 bar. So they can't go, right? Look at this. The number that comes after the decimal is 1 for equation 1, and the number that comes after the decimal for equation 2 is 3. So you can't subtract. And if we cannot subtract, that means that we have to multiply both sides of the equation by 10 again. Now let's do that. If I multiply equation 2 again, please don't multiply equation 1 again by 10, because you still get the same equation 2. What you have to do is to continue from equation 2, you multiply equation 2 by 10. Now 10 times 10 will give you a 100x, okay? It's equal to, and when you multiply this repeating decimal by 10 again, all you have to do is very simple. Move the decimal one place backwards, okay? When you move it one place backward, remember that it affects the bar. It's going to disappear for a while, and hence you have 1. Then when the bar disappears, it becomes a 3. Then you put a decimal place or a decimal point at the back of the 3, and then bring back the repeating decimal, okay? It's now going to be 13.3 bar. Remember, when you move it one place, if it goes across the repeating number, it no longer becomes repeating, but when you drop the decimal point, you have to bring back the repeating number, okay? It's always going to be at the last. So this is now, we can call it our equation 3. Okay, now let's check again if we can now subtract. Let's look at our equation 1. We can see it's 0.13. The number that comes after the decimal is 1. The number that comes after the decimal for equation 2 is 3. Okay? And the number that comes after the decimal for equation 3 is 3. So that means that equation 2 and 3 are perfectly aligned. So we can now subtract equation 2 from equation 3 to terminate or eliminate the repeating decimal. Now let's do just that. And that's how to do it. It's not very hard. It's just really easy. Hence we have subtracting. Okay, let me write it this way. Subtracting 2 from 3. Okay, so when you subtract 2 from 3, what are you going to get? We now have 100x minus 10x, okay? So you subtract the left-hand side together, okay? Since they are like terms, and you also subtract the right-hand side together. This is equal to, we have 13.3 minus 1.3, okay? Don't forget the bar. Okay, so on your calculator, we can now point, on our calculator, we can now point 100x minus 10x, and that gives us 90x is equal to, so on the right hand side, just press 13.3. Okay, just ignore the 3 bar, because you can't really punch those numbers to infinity. It will take you 100 years to do that, or your entire life. So you just punch 13.3 minus 1.3. We're going to get a 12. Okay, this is equal to 12. Have you seen? We have successfully terminated this repeating decimal, and we now have a whole number. Now, to solve for x, what do? You simply divide both sides by 90. This is by 90. And here we can cancel these ones out, and we have that x is equal to 12 over 90. But we can still go ahead and express this fraction in the form of a over b by reducing, okay, the fraction and having it in its lowest term. So what we're going to do right now is that we can divide 12. Let's say if 2 can go, so 12 divided by 2 will give us a 6, and then 90 divided by 2 will give us a 45. Is this still in its lowest term? I don't think it is. So let's try again. We have x is equal to, so let's divide by 3. 6 divided by 3 will give us a 2, okay? And here, 45 divided by 3 will give us a 15. All right. So we can now check and see if our solution is correct by pointing on our calculator. We have 2 divided by 15. Let's see what we're going to get. I'm getting 0.1333333. And that implies that truly 0.13 bar is a rational number, and its value or its equivalence in the form of a fraction is 2 over 15. That's how to do it. Now let's try the last one to see if we can prove that this number is truly rational. And here is our number 3. It's 3.245 bar. Now let's work on it together and see what we shall obtain. We have our number 3 to be 3.245 bar. Remember that the 4 and the 5 carry the bar together, and that means that they are repeating, okay? Hence, we're going to say again, let x be equal to 3.245 bar, all right? Now we can bring it down and call it our equation 1. We say x is equal to 3.245 bar. Remember that the 4 and the 5 are the ones that are repeating. The 2 and the 3 are not repeating, okay? There's a decimal point here. First thing to do is to multiply by 10. So let's multiply by 10 and see what we shall obtain. When you multiply x by 10, you have 10x is equal to, now when you multiply this right hand side or the right hand side by 10, just move the decimal one place backwards, okay? So the decimal will now appear behind the 2. Hence, we shall obtain 32.45 bar. Remember that the 4 and the 5 are the two numbers that are repeating. Now you also have to bring them back after moving the decimal one place backwards. Now the next thing that we're going to do right now is to check, can we subtract? If you look at the number that comes after the decimal for equation 1, this is our equation 1 and this is our equation 2. If you look at the number that comes after the decimal, we have a 2 here, right? And for equation 2, we have a 4 here. That means that you can't subtract them because you end up not being able to terminate the repeating decimal. The goal for subtracting is to eliminate the repeating decimal. So if you can't eliminate it, then it means that you're wrong, okay? Or that it means that that number is not rational. So since they're not the same, and that implies that they cannot be subtracted, we have to multiply again. When you multiply 10 by 10, you get a 100x. 100x is equal to, now it's time for us to move the decimal one place backwards again. If you move this decimal one place backwards, it's going to break the repeating numbers, okay? It's going to break the repeating numbers. And here is what it's going to be. You now have 32, okay, or 324, okay? Then you put the decimal point here. Remember that the 4 and the 5 are repeating at the same time. It's something like this, 4, 5, 4, 5, 4, 5. Not just 4 or 5, but the two of them are repeating at the same time. Now, once you have to be very careful here if you have 2 or 3 numbers that are repeating, because once you break, I would say, the bond, which is the bar, holding the 2 of them together, they no longer become repeating numbers at that time. So that means that you now have to write them separately. As I've written the 4 here, does the 4 carry a bar? No, there is no bar on the 4 because the 4 is not the only number repeating. They're repeating in pairs, right? So you now write 3, 2, 4 points. That 5 has been broken, so you write it here. Please don't use a calculator, okay? Do it manually, because once you understand how to do it manually, you have no issues with solving this very problem in the examination should it appear tomorrow. Now, once you've broken them into 2, and now you have the 4 and the 5 being separated, okay? This is just temporary separation. Now, the next thing that you're going to do is to bring back the repeating numbers again. So once you do that, you now have 4, 5 bar. We can call this our equation 3. Please make sure that once you break 2 numbers that are repeating, right? Remove the bar, okay, when they are separate, but then you also have to bring them back and put them at the back, okay? You're seeing that they're now at the back here, okay? So the bar still remains to show that they are still repeating. But we've broken them into 2 here because we multiplied by 10. Okay, I believe you got that very part. Now we can now ask ourselves, can we subtract? We have equation 1, the number that comes after the decimal is 2. For equation 2, the number that comes after the decimal is 4. And for equation 3, the number that comes after the decimal is 5. So we can subtract. Okay, we can subtract because if we subtract, we will not be able to terminate the repeating decimal. So what do? We multiply one more time by 10. Now when we multiply equation 3 by 10, we have 10 times 100 is 1000x. This is equal to, now when you multiply 324.545 by 10, just move the decimal one place backwards. So this is now going to be 324, and then we have a 5. Then you drop the decimal here. It now becomes 0.45. Remember that the 45 is the repeating decimal or the repeating pair of numbers. Okay, so since we've moved it one place backwards, we can now ask ourselves, can we subtract? Let's check it out. The number in front of the number, let's say, that comes after the decimal in equation 1 is 2. The one that comes after the decimal in equation 2 is 4. The one that comes after the decimal in equation 3 is 5. And then this one here is 4. So we only have to choose these ones. These are equation 4. We can only choose these 2. Okay, you can see we have 0.45 and we also have 0.45. So we can now subtract equation 2 from 4. Let's do that. We have subtracting 2 from 4. And when we do that, what shall we obtain? We now have 1000 x minus 10x. Okay, so left hand side for left hand side, right hand side for right hand side. This is equal to, on the right hand side of our equation 4, we have 3245.45 bar. Then this is minus 32.45 bar. Okay, so now let's subtract. 1000x minus 10x will give us 990x. We have 990x is equal to, we have 3245.45 minus 32.45. We have 3213. 3213. And that implies that you can see that we have eliminated successfully the repeating decimal. Now, the next thing that we're going to do right now is to divide both sides by 990 and solve for x. Let's do that. We divide by 990, divide the other side by 990. So we can now say that x is equal to 3213 divided by 990. But the question right here is this fraction in its lowest term? Let's try and see if 3 can go, to see if we can reduce it further. So 3213 divided by 3, okay, it's giving me 1071. We have 1071 over, I believe that 3 can go into 990. We have 990 divided by 3. Okay, it's giving me 330. 330. Is it still in its lowest term? Let's check it out. Let's try and see if 3 can go into 1071. 1071 divided by 3. Oh, that's amazing. It's giving me 357. We have 357 over. Let's check if 3 can go into 330. 330 divided by 3. The answer is 110. We have 110. Hence, I think this is the lowest term of this very fraction. So we have x is equal to 357 is equal to 357 over 110. So try to verify this solution by pressing or punching 357 divided by 110 on your calculator to see what you're going to get. Here I'm getting 3.245454545 and repeatedly. So this implies that our solution is correct. Alright guys, I thank you for following me to this very point. This is how to express repeating decimals in the form of A over B. And it's also how to prove, one of the ways to prove that a number is truly rational. See you in the next video where I'm going to be talking about irrational numbers. Thank you and bye.